A metal block of heat capacity 80 joule per degree Celsius placed in a room at 20 degree is heated electrically. The heater is switched off when the temperature reaches 30. The temperature of the block rises at the rate of 2 degree just after the heater is switched on. So d theta by dt, initially that when it was just switched on was 2 degree Celsius per second, and d theta by dt when it was just switched off was 0.2 degrees Celsius per second. And assuming eternal loss of cooling, find the power of the heater. Alright, and first off I have to calculate the power of the heater. Fine, so power of the heater can be calculated by ms d theta by dt, and that is 1, because just when the heater is switched on, the power that will be radiated by the heater will be equal to ms d theta by dt, and at initial point d theta by dt is equal to d theta dt 1. So I do have mass can be written as 80, m is assumed to be 1, and d theta by dt is given by 2, so it comes out to be 160 joules per second. Second part, I have to calculate power radiated by the block just after the heater is switched off. So power that is radiated by the block will be equal to ms d theta by dt again, but this time d theta by dt will be 2, because this is the rate of change of temperature just after the heater is switched off. So it will be equal to again 1 into 80 into 0.2, it comes out to be 16 joules per second. Alright, in third part it is asked that we have to calculate the power radiated when the temperature of the block is 25 degree. So first of all, by Newton's laws of cooling, I have power radiated is given by ms d theta by dt is equal to minus of, let's say, k into delta t. Alright, so if I calculate the power at the time when the block, I mean the heater, is just switched off, so at that instant of time d theta by dt will be equal to d theta dt2. Now this value comes out to be 16, that is from this equation, that is equal to minus of k. Delta t will be from 20 to 30, so 30 minus 20, so it comes out to be k equal to minus of 1.6. Fine, now I have to calculate the d theta by dt, or the power radiated at the time when the temperature is 25 degree. So as I told you that power is given by minus of k delta t, I have the value of minus k as 1.6, delta t is 25 minus initial temperature, that is 20, so 1.6 into 0.5, that comes out to be, I'm sorry, it is 5, so it comes out to be 8 joules per second. In the fourth part, assuming that the power radiated at 25 degree represents the average value in the heating process, find the time for which the heater was kept on. Now if this is the average value, then it is giving 8 joules of energy in 1 second, and I have to calculate. Okay, so let's say the maximum heat that will be produced will be equal to ms into delta t, where delta t is 30 minus 20. This is the maximum heat that will be produced, joules. Now I have to calculate the time in which the heater will produce this much of heat. So as I told you that 8 joules of energy is produced in 1 second, so this much of energy is generated in, let's say, t second, and t is given by ms into 10 by 8. Substituting the value, I have value of s as 80 by 10 by 8, so it gives me 100 seconds. That is my answer.